Alright guys, welcome to 6.4. In 6.4 we're talking about factoring special forms or special products. Alright, so let's get started. So let me draw your attention to the top of the page here. Alright, because we're dealing with special products, let me tell you what they are. We first have a difference of two squares. If you have a binomial where both terms are squares, alright, and you subtract the two, then you're going to get a plus b, a minus b, where your first term and your second term live in both, and you just have one of each sign. Okay, let me jump to the third line as well. When you see a binomial where both terms are cubed, whether they're adding or subtracting, they follow this pattern. You have a binomial and you have a trinomial. And the only difference is the first two signs. Everything else is the same. Like how you get your numbers, it's all the same pattern. And I focused on this first line and the third line because these two you really need to commit to memory. If you don't know them, right, then it's a problem. Because there's no third term, it's hard to factor them any other way. So you kind of need to know these terms, right? Now, you can factor these on the second line and get the a plus b all squared with a minus b all squared. You can get that. However, you can factor these by hand, even if it's the AC method. I don't recommend it. I also recommend learning these, but you must learn the first line and the third line. Okay. So let's get started. Starting with number one, we have a difference of two squares. X squared is all squared, is a perfect squared, and 16 is a perfect squared. I will also say that if you haven't already, you should I highly encourage you to look up and memorize the first 15 perfect squares and the first 12 perfect cubes. Okay, well, let's see. This is going to be, anytime I see a binomial with a subtraction like this, or a difference of two squares, it's going to be two binomials that it breaks down to. I'm going to take the square root of the first term, so the square root of x squared is x, and I'll put it in both here and here. The square root of 16 is 4, and I'll put it here and here. And then I have one of each side. It's really that simple. It doesn't matter if the x is the first term or the last term. Right here on 2, right, the x is in the back, but it doesn't change anything. And this is, again, one of the reasons why I say you should memorize all the way up to the 15th perfect square. Right? This is 1 and 1, and this is 15 and 15. If you don't know that 225 is a perfect square, you might think that it's not going to be a perfect square. So, because some of these, as we get into this, you're going to have to take a GCF first before the difference of two squares, the difference of two cubes shows up, right? And you're not going to be able to recognize what's what if you don't know, like, what are your perfect squares, what are your perfect cubes. So keep that in mind. On number 3, you have, just because it's x to the 4th, really a perfect square is any even power, because I can break it in half. So the square root of x to the 4th is x squared. I put it here and here. Square root of 49 is 7. I put it here and here, and you get plus and minus. And again, that's all there is to it. Now, as we get a little more complicated, like on number 4, you still need to be able to recognize, hey, this is the difference of two squares. The square root of 64 is 8 and 8. The square root of 81 is 9 and 9. And so this is going to be 8x plus 9y, 8x minus 9y. Number 5, remember, this is a difference of two squares. Look at what we've done so far on 1 through 4. It's a difference of two perfect squares. Yes, on number 5, we have a perfect square in x squared, we have a perfect square in 81. But it's not a sum, or it's not a difference, it's a sum. So this is prime. I can't factor this. Okay. On 6, as I said before, sometimes you're going to have to take a GCF out first before what you're looking for is actually going to show up. So 7 goes into 63, and both terms have an x, so I'm going to put out 7x. And that's going to leave me with 9x squared minus 1. Because remember, when your GCF is one of your terms, you replace it with 1. Okay, now, inside the parentheses is the difference of two squares. So it's going to be 7x plus 3x plus 1, 3x minus 1. Again, difference of two squares. Square root of 9x squared is 3x. You put it in both terms, and the square root of 1 is 1. So you put it there. All right, switching gears. Number 7. You have x. The second sign is positive, so both signs are the same as the first. So minus minus. Okay, so that's going to be what times what is 9 and what adds to 6. So 3 and 3. So this is one of those situations where you have x minus 3 all squared. And if you recognize the pattern for the second line here, that's going to be this one right here. We have the first term is squared, the last term is squared, and you have another term that is subtraction. That's exactly what's going on here. This is a perfect square, this is a perfect square. And if you take both the square root of both of those terms and multiply them together and double it, you get negative 6x, which is negative 3x, negative 3x, you get negative 6x. So that's where that comes from. Okay, so once again, you can do that either straight up or with the AC method, right? But I still highly recommend you using these special formulas. Okay, so this can be x minus minus. Factors of 4 are 2 1 and 4 and 2 and 2. Well, that doesn't give me, uh, that doesn't result in a 2 in the middle. So this is prime. This can't be factored any further. Number 9. So you have x plus 4y and 4y. So that's going to be x plus 4y all squared. Okay. Number 10. Number 10, again, you might want to look for a GCF, especially if everything's even. So I got 2, so pull that out. Can't pull any letters out. So it's going to be 9x squared minus 24x plus 16. Right? This is one of the ones where I would not want to. You could factor with the AC method. All right, but 9 times 16 is 144. And that's starting to get a little big. While you can do it, and you're more than welcome to do it, right? Let's try something else. Okay, well, if you notice that your first and last term are perfect squares, let's try this. So my perfect square for the first one is going to be 3x, so I'll put it in both. Perfect square for 16 is 4. My second sign is positive, so both are the same as the first. Now, this looks good, but let me test it. Okay, so that inside factor and the inside product is going to be negative 12x. The outside factor is going to be negative 12x. Well, that's going to be negative 24. They're actually going together. So this works. So if you see something like this, where either before you take a GCF or after you take a GCF, you see something like this show up, and you could work it AC method, but let's give this a shot. If that first term and last term are perfect squares, try something like this. And then before you actually say it's your answer, you can check that middle term to see if it works out. So this is going to be 2 times 3x minus 4 all squared. Okay, x. This is going to be a difference of 2 cubes. And so it's going to be a binomial and a trinomial. And the trinomial is completely based off of whatever the binomial is. So we need to get the binomial correct. Right, because this is x cubed minus 216, I'm going to take the cube root of x and get x. I keep the same sign. The cube root of 216 is 6. Right? And then for my trinomial, I look at my binomial and I square my first term, so it's going to be x squared. I multiply my two terms together and change the sign. So x times negative 6 is negative 6x. If you change the sign, that's going to be positive 6x. And then I square my last term. So 6 squared is 36. And that's it, guys. That's all you do. On number 12, you have the cube root of 64 is 4y. The cube root of y cubed is y. And then minus the cube root of 1 is 1. Okay, once again, you're going to get a trinomial. This is completely based off the first one. So you square your first term. It's going to be 16y squared. You multiply your two terms together. It's going to give you negative 4y. And you change the sign. So it's going to be plus 4y. And then you square your last term. And because you're squaring your last term, it's always positive. So it's going to be plus 1. Okay, there's that. On number 13, we've already dealt with 216 on number 11, so I kind of know where this is headed, but y to the fourth means nothing to me, and I have a y here. But because there's a y in both terms, looks like I might have a TCF with that. So it's going to be 216y cubed plus 1 after you take out the y. Right, so now I can factor the inside. So it's going to be 6y plus 1. Okay, now square your first term, it's going to be 36, y squared. Multiply your terms together, it's going to give you 6y. Change the sign, it's going to give you negative 6y. And then square your last term, plus 1. Okay, and there you go. That's 6.4. Hope you got something out of it. If you have any trouble, please reach out, and I'll see you in the next video.